This is Earth, the place we all live. However, if we want to explore more in the universe than just our planet, we're going to need a way of getting there. So how can we explore places such as the moon or Mars or any other interesting things in the cosmos? Well, we need rockets. Before we talk about the science behind how we can use rockets to travel to space, we first need to understand what a rocket is. If rockets have propellant and an engine and can get off the ground, what makes them different to a weapon, such as a missile, or another source of air transportation, such as a plane? Well, as I talked about before, rockets have fuel and an engine, but that goes the same for planes and for missiles. So what is the difference? Well, on Earth there's air everywhere, but out in space there's none. So, fuel needs oxygen to burn. So, how do we do that? Well, planes use intakes, which basically take in the air around them and burn them with the fuel to create thrust. This relates to Newton's third law, which is everything has an equal and opposite reaction. When the engine exhausts fuel out the back of the aircraft will travel in the opposite direction, as you can see by this example here. Then how do rockets work in space? As we said before, there's no oxygen in space, and liquid fuel needs oxygen. Well, rockets actually store oxygen on board in their fuel tank. When they're mixed and burned together, they create this. There isn't just one type of fuel that rockets use. In fact, there are many different types of fuel that rockets use, but they can be summed up into two categories: solid fuel and liquid fuel. Let's have a look at solid fuel. Solid fuel is basically solid propellant, unsurprising from the name. And it is stored in solid rocket boosters, or SRBs for short. These are basically controlled explosions of a bunch of hot gas being exhausted out of the engine nozzle. The thing with this is, it is a lot more powerful than most liquid-fueled engines. However, the only downside to this is solid rocket boosters are basically uncontrollable, and you can't throttle them up and down. You can only ignite them once, and once it's turned on, it just keeps going until it's out of fuel. So, liquid fuel is usually the better option. But SRBs aren't completely pointless. You can use SRBs on the side of rockets to give you a bit of an extra kick off the launch pad, to get you more speed and indeed more height on your merry way to space. Many rockets use this technique for deep space missions, some of which are the SLS and the Ariane 5, and many others. Now let's talk about liquid fuel. Liquid fuel is essentially the opposite to solid fuel. When paired with a liquid-fueled engine, the engine can actually control the amount of liquid propellant that goes through it. Not only this, but it can steer the rocket through the air and throttle it up and down. And in most cases, be activated multiple times when using liquid fuel. This obviously makes liquid fuel the more convenient option for space missions, especially going to other planets and moons, and going very far distances in general. For example, all of the Apollo landers used liquid-fueled fuel tanks and liquid-fueled engines. This is so they could control their rate of descent and essentially steer the rocket to the moon's surface. So this is great. Now we know what a rocket is, and also the different fuel types we can use. But we've got one other obstacle: the Earth itself. Let me explain. The Earth has a thick atmosphere that basically surrounds the planet. This atmosphere allows for life to thrive on Earth. The only downside to this is it makes it a real pain for space travel, as obviously to get to space, you have to exit this atmosphere. To make this challenge a bit easier for our rocket, we need to consider two things: aerodynamics and efficiency. Let's talk about both of them. To put it as simply as possible, efficiency is essentially how far your rocket can travel through space. But how can we make our rocket be efficient? Let's have a look. So I've made this rocket here that has really high thrust, so it should be able to escape the atmosphere really quickly. And then we can continue on in space. So, as you can see, we get off the launch pad extremely quickly, but we basically instantly run out of fuel because, well, it doesn't have a very big fuel tank. So, how can we create a rocket that's more efficient? Well, let's try adding a smaller engine and more fuel for it. As you can see though, this engine is still quite powerful. And unfortunately, it's just still draining the fuel too quickly, and we don't make it to space. When most rockets are flying in space, they use more efficient, smaller engines that don't deliver as much thrust. maybe if we use this here, we'll have a high efficiency rocket. But as you can see, firing up the engine here, the rocket doesn't get off the ground. This is because this engine is designed for spaceflight, and in the thick, soupy atmosphere of Earth, it doesn't work too well at all. But now we've tried everything we can to make an efficient rocket. So, how can we actually make an efficient rocket? Well, the truth is, we need stages. Stages are essentially different parts of a rocket that, when they have served their purpose, break off so that the rocket can reduce its weight and continue its merry way to space. Let's have a look at how we can incorporate this. Most rockets, in their upper stage, fly in space. This is why we're going to use a vacuum-efficient engine, which will burn for long periods of time, but won't essentially give us much thrust. But it shouldn't matter, since we will be in the vacuum of space. Now we're going to create a first stage. We're going to use a bigger, larger fuel tank, with more fuel inside it, and we're also going to choose an engine that works well inside Earth's atmosphere. Now we can try launching. When we take off, we do go pretty fast off the launch pad, however not as fast as we did before. As you can see, our first stage has now ran out of fuel, but we are high in the atmosphere, and now we can separate that stage and move on to our less thrust but more efficient vacuum engine. With this loss of weight and gain of efficiency, we can easily get to space. Now that we know how to create an efficient rocket, let's talk about aerodynamics and what they mean for our rocket. As we mentioned before, the Earth's atmosphere is quite thick, so we need an aerodynamic rocket. Aerodynamics are essentially different parts of the rocket that help to steer the rocket and help it also be efficient on its climb to space. Let me show you what I mean. I'm going to launch this rocket here. As you can see, it has a powerful engine and fuel tank, and it should be able to get to space. And as you can see, it takes off quite quickly. However, the air seems to be pushing against us, and this is extremely hard to steer properly. And as you can see, the air pushes us on the side, and we essentially flip over. So how can we fix this? I'm going to try and make this rocket more aerodynamic. Maybe if we make it smaller and smaller until it gets up to that little capsule, which is going to be the top of our rocket. Maybe this will make the air travel down the rocket instead of just slam into it. This hopefully should fix our problems of flipping over. We'll add them on just like this, and then we can put our capsule on top. I think what we should also do though is add some stabilizers. This should help us when flying and let us steer the rocket better. Already taking off, you may notice it's going off the launch pad a bit slower. That is because obviously we've got this extra weight. However, this is being a lot more stable. The air essentially hits the rocket at the top and then slopes down the sides and peels off. This means our rocket can go a lot faster through the thick, soupy atmosphere and get to space more easily. So we've talked about a lot of stuff in this video, so let's do a quick summary. Rockets are different to planes, as planes fly in the atmosphere, and rockets basically carry oxygen on board to feed their fuel, whereas planes gather the oxygen from the air around them. Rockets are different to a weapon such as missiles, because missiles contain more explosive material that will explode on impact, and obviously, they don't fly in space. There are two types of rocket propellants, solid fuel and liquid fuel. Efficiency and aerodynamics are extremely important aspects when designing a rocket. Many rockets that go to faraway destinations have multiple stages. This is so the rocket can lose weight and lose unnecessary parts. And now for the definition. What actually is a rocket? Well, a rocket is essentially a controlled explosion of hot gas and fuel that ejects through an engine nozzle and sends it up to the sky. But it's not just any controlled explosion. It's a controlled explosion that continues to push humanity towards the stars. Thanks for watching, guys. I'll see you in the next one.